Hello everyone, welcome to Politics of China. Today's topic is Bend the Road. China's carbon-based chips have made significant achievements. As the heart of electronic products, the annual global demand for chips has reached trillions of pieces. Everyone wants faster chips for electronic devices and longer battery life. Chinese experts told reporters that the development of carbon-based chip technology has a wide and far-reaching impact on public life. The advent of 5G technology will make the city into a smart city, healthcare, wearable electronic devices, the Internet of Things and biocompatible devices. These are inseparable from the huge amount of data computing, need to have a powerful processing power of the chip to do support. In the traditional process, these chips have a unified core material, which is silicon. Currently, silicon-based chips have entered the 5 nanometers era, and are even exploring to 2 nanometers and 1 nanometer, which means that the performance of silicon-based chips is approaching the physical limit. Since entering the 21st century, the search for chip materials that can replace silicon has become a hot topic. At that time, the entire academic community felt that silicon-based microelectronics was actually going downhill. The academic community would consider in advance what the future material to replace silicon would be. Chinese experts said that the potential of traditional silicon-based chip materials has basically been tapped out and cannot meet the needs of the industry's further development in the future. Enabling new materials is the way out to fundamentally solve the chip performance problem. Current research shows the comprehensive performance of carbon-based chips prepared with carbon nanotubes can be hundreds or thousands of times better than that of silicon-based integrated circuits, which has become the consensus of the academic community. But this is only the ideal state. How to make it a reality? For the team, most of the problems encountered in this process are new. We can only think of ways to solve them one by one. The first is to break through the material bottleneck and master carbon nanotube preparation technology. After 10 years of technical efforts, the team abandoned the traditional doping process and developed a whole set of undoped preparation methods for high-performance carbon nanotube transistors. Carbon nanotube materials are so tiny that they are invisible to the naked eye. Chinese experts describe that the diameter of a human hair is almost tens of microns or tens of thousands of nanometers, while the diameter of this material is tens of thousands of the hair. It cannot be seen with an optical microscope, but only with an electron microscope, and at the same time, it has to be manipulated so that it is arranged in a certain order. How to do? Fortunately, Chinese experts have done a lot of electron microscopy-related research before, and have some experience in observing and manipulating small things. 2017, the team prepared for the first time a carbon nanotube transistor with a gate length of 5 nanometers, which is the world's smallest high-performance transistor to date, and has a combined intrinsic performance and power consumption index of about 10 times better than the most advanced silicon-based devices. This world's smallest high-performance transistor has a combined advantage of about 10 times over the most advanced silicon-based devices in terms of intrinsic performance and power consumption, and its performance is close to the theoretical limit determined by the quantum mechanical inaccuracy principle. In 2018, the team made another important breakthrough by developing a new principle of ultra-low-power Dirac source transistor, which laid the foundation for the development of ultra-low-power nanoelectronics. In the same year, the team prepared small-scale integrated circuits with high-performance transistors, reaching a maximum speed of 5 GHz. In 2020, the team prepared for the first time the high-purity, high-density carbon nanotube array material required to reach large-scale carbon-based integrated circuits, and used this material to first realize carbon nanotube integrated circuits with performance beyond that of silicon-based integrated circuits, with circuit frequencies exceeding 8 GHz, ranking among the international leaders. The team's persistence over the past 20 years has proven to be the right thing to do. At present, China has basically mastered the technology of preparing carbon nanotube integrated circuits and is able to process them out in the laboratory, and the performance is by far the best in the world, with circuit frequencies tens of times higher than those developed in the United States. In March this year, Chinese experts sat in their offices and talked to reporters about the latest progress in research, with full confidence. In the eyes of Chinese experts, carbon-based chips will undoubtedly be the best option to support a digital economy running on these technologies. China's ultimate goal is to have carbon-based chips become mainstream chips within 10 to 15 years, widely used in mainstream electronic devices such as mainframe computers, data centers, and cell phones. Chinese experts told reporters that school labs can already prepare some medium or even large-scale integrated circuits using carbon nanotube materials. It's no problem to make a calculator or something like that. But to use it to make super large-scale integrated circuits is not yet possible. Chinese experts say that the current development of the integration of carbon-based chips is still a long way from the world's commonly used silicon-based chips. Where is the difference? Chinese experts explained that in order to achieve ultra-large-scale high-performance integrated circuits, it is first necessary to prepare ultra-high semiconductor purity, paralleling, high-density and large-area uniform single-walled carbon nanotube arrays on a large-area substrate. What is even more difficult is the need for a dedicated industrial-level R&D line, which is not available to the BYU team. Under the school's existing experimental conditions, the most complex carbon nanotube chip that can be made has an integration level of only a few thousand, or at most a few 100,000 transistors, and the size is still micron level, while the most advanced silicon-based chip in the world today has 50 billion transistors, each with an area size of only about 100 nanometers. It's too far off. Dedicated design tools for cutting-edge carbon-based chips are equally lacking in China. According to Chinese experts, there are no longer insurmountable obstacles in principle for carbon nanotube-based undoped CMOS technology, but the mere completion of existential verification and possibility studies and demonstrations in the lab does not mean that carbon-based chip technology will be able to complete technology landing on its own and be commercially competitive. There is still a lot of work to be done in between to turn the school's technology into an industrialized technology that can be produced at scale. At present, there are still many problems to be solved in the engineering and industrialization of carbon-based chips, and it will take a long time and a lot of investment. Precision production is very difficult. Chinese experts say that although China is a big manufacturing country, it is still far from being a manufacturing powerhouse. The reality is that it would take a lot of money to achieve scale-up of carbon-based integrated circuits even in a laboratory, let alone building factories, acquiring advanced equipment, and refining every step of the way. Chinese experts point out, in comparison, China's investment is still too little. Therefore, the support of the community is crucial to the development of carbon-based chips. The entire silicon-based chip research and development, China is lagging behind a lot. Silicon-based chips have been developed in the United States for more than 60 years. The Chinese state has no significant contribution in which materials, equipment, computer software, manufacturing processes, etc. are purchased from others. In fact, this is not just stuck neck, but completely subjected to others. In the view of Chinese experts, it is not realistic to overtake on the road of silicon-based. China needs to change lanes and drive to the road of carbon-based. This is a new road for the world, and China is still in a relatively leading position. China needs to develop its own integrated circuit technology and have its own technology to not get stuck in the West. According to Chinese experts, China should seize the historical opportunity to build on its existing strengths and avoid its weaknesses, start with materials, make a comprehensive breakthrough in the existing mainstream semiconductor technology, develop a chip technology that is completely independent and controllable by the Chinese, and realize the overtaking of the Chinese core by developing carbon-based chips. Recently, China's Ziguang Zhanrui announced on its website that its 5G and 4G platforms have been upgraded in tandem with Android 13. This rather low-key release may not attract much attention, but for those who are familiar with the electronic information industry, they know very well the importance of synchronous adaptation. A chip with good performance is only the first step to complete a wide range of work. It is more important to be able to better adapt and compatible with the system, in order to play its true strength. At the smartphone level, the 5G SoC chip is the key brain of the device, and whether it can be better adapted to the system depends on the overall comprehensive experience of the phone. Being able to participate in the debugging and certification work of the major version update in advance is a kind of affirmation in itself. As the most representative network information technology in the world today, 5G is a key information infrastructure that supports the high-quality development of the real economy in the era of Internet of Everything and deep human-machine interaction. Information infrastructure. Since the commercialization of 5G, from operators to communication vendors, all of them have made the construction of 5G a key direction, hoping to drive the digital transformation of various industries and the development of the digital economy by continuously improving 5G infrastructure.